Hi, I'm Andrew, and this is part 6 in the Advent of Code series where every day I'm trying to solve a new code challenge. The previous videos are on a playlist on my channel called Advent of Code 2022, and if I'm able to complete any challenges for the day, I'll upload the code that I write onto a public repo. The link for that is in the description. So let's get started for today, part 6. For day 6, we have tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way towards the starfruit grove. As we go through the dense undergrowth, one of the elves gives you a handheld device. He says that it may have many fancy features, but the most important one to set up right now is the communication system. He's heard we have significant experience dealing with signal-based systems, so he's going to give us one of the malfunctioning devices. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of random characters that the device receives one at a time. To fix the device, we need to add a subroutine that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of the packet is indicated by a sequence of 4 characters that are all different. The device will send the subroutine a data stream buffer, which is our puzzle input, and our subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker. So given this example, after the first 3 characters, MJQ, there haven't been enough characters received yet to find the marker. The first time a marker could occur is after the 4th character is received, making the most recent 4 characters MJ, QJ, because J is repeated, that isn't a marker. So the first time that they're all unique is when the 7th character is there. So that would be JPQM, which is right here. Okay. So in this case, the subroutine should report value 7 because the first start of packet marker ends after the 7th character. Okay, so for these examples, the first marker ends after character 5. That's because VWBJ. Okay. So we just need to put our puzzle answer is going to be just an integer like this. So let's get started. I think we can do an okay job of processing this input by windowing that. Let's see. We just have one line. Is that all we need to check, is just a single line? I guess so. It's just a really long line, but we should be able to work with that. Okay, so we can probably window these and just check. So windowed is a is a list extension function that lets us, or it's a function on lists where it takes a certain number of items and it slides down the list. So if we take 4 at a time, we can check if the strings, let's see, so input windowed, we're going to have a list of strings, and each string should just be 4 characters long. I think that's what we'll get. And we'll say strings. We can just check if distinct size is still 4. What do we have here? We need to return a integer. What are we doing here? So distinct. Oh, that's okay. So we're returning a unit from this. So what we need is to we're going to set an answer here, and we'll just assign it as 0 to start, and then we'll go over each item and we'll return the answer. And then whenever we find an item that satisfies this, we'll set our answer to it. So we will say if our strings are all the same, or are not all the same, if they're all different, then our answer is we're gonna get the index, because that's which like window in the sliding list we're on. By knowing which of those we're on, we need to do some math to figure out what the last item is on it. So I think the index, it would just be the index plus 3, right? Because if we're on the second item, for example, we would be looking at these 4, and our index would be 1, and we would say 1 plus 3. Actually, we need to add 4 because the index started at 0, and I think the examples they're using a 1-based indexing. So I think this will work. Yeah, let's see. We'll just test it with one of these examples quick. Yeah, we'll just replace that and undo it. So to get the answer, it should be the oh, it's still at 0. Okay, it's supposed to be the 4th character. Oh, it's not the 4th. So in this case, the answer would be 7. So that's what we're looking for, is the answer of 7. Let's just see why this isn't working. Input windowed should give us a list of all of our stuff. We'll set a debugger. Yeah, evaluate, see what's going on. So input windowed 4 is going to give us this. Why is that? Input window. That's because there's only a right, of course. So in the line, this is the only item inside the list. So we need to actually break out, right, so that each of these are like their own item. Okay, so we are going to, instead of using input, we're going to take the first item from the input, and then the string will be windowed, which will make each of these a character. Yeah, so strings is just a string itself. So strings, if we say to a list, that'll make it a list of characters. There we go. So let's run this again with our input, and we should get 7. Here, stop the breakpoint, rerun the program, and that gives us 30. 30. I'm not sure how it could be 30. Okay, so we'll just debug again, look at what the list looks like. I'm probably missing some small detail. So input 0 would be our string, and windowed with 4 is going to give us a list 4 items at a time. So it starts with M, J, Q, J, then it goes J, Q, J, P. So that's good. And let's just take the first list and say to list and say distinct. So the first list, distinct, that's correct, right? Let's take the second list. Second, or actually we'll just take index second. So this gives us another one. So I think it's the third. So here we've got size of 4. To list distinct size. This is 4. So I'm not sure why. Oh, of course. Because we're not breaking. Yeah, so it was something simple. We're not exiting, so it's taking the last time. There are 4, so we can honestly just can we just return the answer here? Return answer. So that's fine. We would really want to break with for each. I'm not sure that we can really do that. So there's our answer, 7. Okay, so now we will redo it with our actual puzzle input. I didn't mean to debug. Okay, so our answer is 1848. Let's check it. And that is the right answer, so that's good. Continuing to part 2. What do we need to do? The device's communication system is working. Oh, it's detecting packets, but it still isn't working correctly. It looks like we also need to look for messages. So a start of message marker is just like the start of the packet marker, except it consists of 14 distinct characters instead of 4. So here's the first positions of start of message. Okay, so we just need to change our window of 4 to window of 14, I think. Let's just try that. Our window would be 14, and we would add 14, and we would check for 14. Oh, I should have moved this over to part 2 instead. So we'll do that, undo these changes, and put this for part 2. Run it. So let's try 2308. And it should be the first time we run into it. All the other logic should be the same. And there we go. Got the answer. So that is it for day 6. I will clean up the code a little bit for this loop so that we're not wasting the return answer here. Otherwise, that's it. So thanks for watching, and I'll be back tomorrow with a new video.